Bismillahirrahmanirrahim. Assalamu alaikum. So, in this lab, we learn about how to save variables in our Octave or Matlab workspace, and how to load variables, how to load data into our workspace variables from files that are stored on our hard drive. Okay? So the only two things that we learn in this particular lab is how to save some data from our Matlab or Octave workspace onto a file on the hard drive, so that you can access it over and over again. You don't have to run the code to generate that data. Okay? So as you might have noticed, in some particular tasks, MATLAB or Octave takes a lot of time to do some certain computations. So if you have done some computations, and if you have generated some important data or results, you might want to store those results on your hard drive, so that you can access those results later on whenever you need to access those results. Okay, so in order to be able to do that, you can create files on your hard drive, and you can store data or workspace variables. The data that you have in Octave or Matlab, it basically lives in the form of your workspace variables. So you can store any workspace variable on the hard drive, and similarly you can load data from files of a particular format, of certain particular formats from your hard drive into your workspace. So I uploaded certain files onto our Google Classroom, and I guess there was a certain confusion, you could not open these files directly. Okay, so if you bring your mouse pointer to this file, what you see here in the screen tip is that its type is shown as Microsoft Access Table shortcut. But this is not actually Microsoft Access Table. This is basically MATLAB table format. So this particular file, 97.mat, 98.mat, 99.mat. Now these are this is data. We'll talk about this particular data in a little more detail. But this data is in MATLAB table format, .mat or .mat. Okay, so this is basically a data file, and we will load this data file into our MATLAB workspace, and we will see what kind of data it has. We'll talk about this as well. Similarly, we have other files, 105, and here I have named it as IRF, 106 IRF, 107 IRF. I'm not sure whether I have uploaded all these files on our Google Classroom. Let me check. No, I only uploaded these files, 97.mat and 105 IRF.mat. Now these two are different, they are definitely two different files, and they store different data. Let me talk about the data that is stored in these files. I'll show you that data, and then we'll see. Okay, we have other files as well. We have this test1.txt file. We can open it. I have uploaded this on the Google Classroom as well, and as you can see, here we have these integer values. These are integer values, but since this is a text file, so these are all stored as ASCII characters. Okay, so this is 45. This is the ASCII character 4 and the ASCII character 5. So it is stored as an 8-bit ASCII code. This is also stored as an 8-bit ASCII code. So this is 16 bits of data, and this is basically character 4 and character 5. Similarly, this is 1, 2, 3, 5. So these are 5 characters. So 5 8s are 40. These are 40 bits of data, okay, or 5 bytes of data. So these are basically, this is text data. These are ASCII characters that are stored in the test1.txt file. You can read this text file into your workspace. Okay, so we'll demonstrate basically these things. So how can we do that? And what happens when you do that? So for example, if you have such a text file, we can change it as well. You can read it into your MATLAB or Octave workspace. How can you do that? Okay, So in order to do that, let me clear all the variables that we have. You need to use the load command. You need to use the load command. So in this lab, I may not write detailed script files because I just want to demonstrate the load command and the save command, okay, or the load function and the save function. So I just want to demonstrate these functions. That's why I may not write extensive script files. I may only be working on the command window, command window. So let's start learning these things. So first of all, let me open this file, the one that I've already uploaded on the Google Classroom, 97.mat. Okay, so let me open this file, 97.mat. It is available on Google Classroom as well. So let us load this file. In order to load a file or the variables stored in a file into our workspace, so we use the load command. We use the load command. So this is how, or we use the load function. This is how you write the load function. Okay, let me zoom in as well if I can. I want to increase this font size so that you can see it clearly, although I guess it is clear enough, but in any case let me increase it further. So default, where is the command window? Terminal. Say I increase it 24. Okay. Okay, so if you go to edit preferences and you go to the terminal tab, so you can increase the size. So I guess now it is a little slightly bigger. So in order to load variables or data stored on your hard drive in the form of some file, in this particular case the file that stores that data is in the mat format, Matlab table format. MAT stands for Matlab table. So it stores the variables in some particular format. For you as a programmer or as somebody who is writing Matlab script code, what is important is that these two functions, load and save, they give you the ability to store data in a file on a hard drive, and to read or load data stored in some file into your workspace. So you can do this very easily using these two functions, and this is what is important. You should learn about that. So if I want to load all the variables stored in this particular file, 97.mat, so I can use the load function. And the load function needs certain arguments. So what are the arguments that you can provide to it? So first of all, you need to specify the name of the file, and the name of the file should be specified as a string. Okay, so that's why we have the single quote character or the double quote character. You can use either, no problem with that. So we are going to load the file 97.mat. You also need to specify the file extension. So .mat is the file extension. So every file type has a certain file extension that basically allows the operating system to distinguish that particular file from other file types. So you might know, for example, text files, ASCII text files, they have the file extension .txt. You must be aware that music files, audio files, they have the extension .mp3. Similarly, video files, they have the extension .mp4, .avi. So file extensions are a way through which operating systems basically track the type of data stored in that file. Okay, so 97.mat, this is the full name of this file. Mat is the file type, Matlab table type of file, and 97 is the file name. So if we want to load all the variables stored in this particular file, So you can simply say load 97.mat, and like you can see I did not specify like the drive and the subfolder and everything. Why? Because our current directory is this particular directory. Okay, if my current directory is not this particular directory in which this file is stored, then I need to specify the full file path. So I have to specify F drive or E drive and all the subfolders and all the folders and subfolders in this path in order to access this particular file. Okay, but if this particular file is in our current directory, and we are in here, the current directory for Octave or Matlab is also set to this directory, then you don't need to specify the full path. Okay, you can simply say load and then name of the file dot type of the file. Okay, so this argument is enough, and you can put semicolon, and then when you press enter, so all the variables stored in this particular data file, they will be loaded, and you can see these variables here. Okay, you have one variable is x09. Well, the name of that variable is x097 rpm, revolution per minute. So rpm is here 1796. Okay, so this data was basically measured for a bearing. So you know what a bearing is, bearing or a ball bearing or roller bearing. So bearing, they are basically very commonly used components, mechanical components, and they exist almost everywhere. So the fans that you see, the ceiling fans or the pedestal fans, your cars or cycles, any mechanical or electromechanical device which undergoes rotatory motion, so it has some form of a bearing. So bearings are used to reduce friction. They basically reduce friction and make the circular motion, the rotatory motion, very easy or frictionless. So that is basically the purpose of bearings. And bearings are also very important because in all these electromechanical or mechanical components or devices or equipment, bearing is one of the components that fails most frequently. Okay, so bearing can develop different faults, and once a bearing becomes faulty, so that equipment can become noisy. Okay, so for example, if the ball bearing breaks a ball, or there is some fault on its races, the inner race or the outer race, so then that bearing becomes noisy. Okay, so that bearing becomes noisy, it can break down, it can jam, it can do plenty of bad things. So people, they want to know about the health of the bearing, and one of the ways through which they can basically do that is by installing accelerometers. Okay, so accelerometer is a device that measures the acceleration of vibration. So whenever there is a component, a motor or any other device that is rotating and it has bearing, so the accelerometer is installed on top of the bearing housing, and whenever something is rotating, so there is always vibration. Okay, so that you know. So the accelerometer measures that vibration, and by looking at changes in that vibration, like there are techniques that people can use to find out if there is a fault in that bearing, if that bearing is problematic. Okay, so this is one such measurement data. So this data is basically the instantaneous acceleration. This data is basically the instantaneous acceleration. Instantaneous acceleration of what? Instantaneous acceleration of the vibrations of a bearing. Okay, so I'm just giving you like why am I doing this explanation? Because I want to tell you that this is real data. Okay, and this is useful data. And when you are doing practical engineering, when you work for a company or when you work in an organization or something like that, so you might be required to handle such data. It may not be bearing acceleration data or some other, it can be any other data, but it can be real data that comes from real sensors, and you might be asked to process that data. Okay, so in this particular lab, we'll just learn how to load that data into Octave, or Matlab Workspace, how to display that data. Okay, so we are going to learn only about that. So if you see, we have in this particular file 97.mat, we had three variables. One stored the RPM for which this data was recorded, and that RPM is 1796 revolutions per minute. That is the value. And the other is, these are two vibration acceleration signals. Okay, so one is for this is a time signal. Okay, so this is not frequency information. So basically at different instances of time, to be precise, like the sampling rate for this signal is 12,000 per second. So in 1 second 12,000 measurements were carried out. Okay, so for 1 second 12,000 readings of the vibration acceleration were taken by the accelerometer, and those readings were then stored. In all, we have these are like 243,000, almost 244,000 samples. Okay, so you can divide it by the sampling rate and you can find it out for how many seconds this signal was recorded. Okay, so there was a bearing that was rotating at 1796 revolutions per minute, and for that bearing these many readings, 243,938 readings were carried out, were recorded. Okay, so as I mentioned earlier, these recordings were these measurements were taken at a rate of 12,000 samples per second. Okay, so if we divide the number of total samples, one sample is basically one measurement of your quantity of interest. So here our quantity of interest is the vibration acceleration, the acceleration of the vibration of a bearing, how quickly or how sharp or how strong that vibration is. And so that is one measurement of that quantity is one sample. Sampling rate is how many samples do you take in a unit time, or how many measurements do you take in a unit time. So these measurements were taken at 12,000 per samples. These are the total samples. If I divide it by 12,000 per second, so this is basically this signal is for 20.32 seconds, almost 20 seconds. For 20 seconds these recordings were carried out. So you can see, when you're working with real data and working on real problems, so you can end up with immense amount of data. Okay, so this is just 20 seconds of data, and that 20 seconds of data has consumed around, say this is a double array. Okay, so 243,938 multiplied by 8. Okay, and say divide by 1024. So it is around 1900 kilobytes or around 1 or 2 megabytes. So this is 2 megabytes of data. 2 megabytes of data for just like 20 seconds of the measurements. Okay, so this information is not like related in any way to the load and save function, but this is the data that you will be working on. So you need to know like what this data is about and where does it come from. And this is real data. Okay, this is real data. That's why like we are talking about it. Now let's display this signal. Let's display this signal. Okay, so we have two signals. One is DE time. Okay, so X097. So this is 97 is the file. DE means drive end. FE means fan end. So for the experimental setup for which this data was collected, so there were two bearings. One was on the drive end, so, and the other was on the fan end. So to the operator's one end, like the motor was connected to using a belt to one end of the equipment, and then on the other end there was a fan. So there were two bearings, and basically like you could collect data for two bearings. So this is basically data for two bearings. This is for the drive end bearing, this is for the fan end bearing. Okay, So let us just display the signal, like how does this vibration acceleration looks like. Let us just plot it. So what you need to display it, you just need to plot it. Okay, so what do we want to plot? We want to plot this workspace variable. Okay, what is this? This is X097 underscore DE underscore time. So let's just display it. The plot function, you might ask, it receives two arguments, x and y. You can give it just one argument. It will be treated as y, and x would be the integer values 1, 2, 3, 4, 5. So x will be the sample number here. Okay. So let's just plot it. Okay, so this is the vibration acceleration signal. Okay. This is the vibration acceleration signal. Okay, so I hope you can see it. This is how the vibration acceleration varies with time. So on the x-axis we do not have the real time value, it is the sample number. Okay, we can convert it into time. So there are 12,000 samples per second, so we can convert the sample number into second. Okay, we can convert it by one simple technique is that if we divide the sample number by the 12,000, so we can basically convert it into time. Okay, so that is right now that is not that important. The important thing is that you should know how to load a given the variables stored in a given file into your Matlab or Octave workspace. You should know how to do that, and we do it using the load function. And then those variables are available here. Okay, those variables are available here, so you can access those variables. Okay, now there's another variation of this particular load function. Let me clear these variables. I need to clear these workspace variables. Okay, the other version of this load function is that if you know like which variables are available in this file, which variables are available in the file 97.mat. For example, if you know that. Okay, so this is the file 97.mat, and we do not want to load all the variables stored in this particular file. We just want to load a particular variable. Okay, so what is that particular variable? Say for example we just want to load X097 underscore DE underscore time. We just want to load this variable. So you can do that. You can specify the file name within double quotes or single quotes as a string, and you can specify the variable that you want to load within double quotes or single quotes as a string. So the load function will only load this particular variable from that file. So it must exist in that file. The variable name must be correct. It must be there. Okay, so it will not load the fan and data. So that is how you might save some RAM. Okay, so otherwise all the variables will be loaded and they will be available in your random access memory in some way, and they will occupy space in your random access memory. If you don't want to do that, so you can specify a particular variable that I want to just load this particular variable from this file. You can do that. And if you do that, so here you see you just load that particular variable from that file. Is this clear? So I hope like this is easy. There is nothing difficult about it. This is easy. And here we just looked at loading variables, workspace variables from .mat files. Okay, Matlab table files from those files. You can also load data from text files. You can also load data from text files. So how can you do that? So I'll give you this example. We have here this particular text file. I have created another text file, test2 as well, but that is for some demo. So we have this text file test1. Okay, and test1 has this data, and this data is stored in the form of ASCII characters. So these are all ASCII characters. These are all ASCII characters. Okay, so if you have some data stored in a text file, you can load that data into your Matlab or Octave workspace, and you can work on that data. How are you going to do that? Okay, so in order to do that, you are going to use the same load function. You are going to use the same load function, but you are going to let me clear this particular variable. You are going to specify to the load function that the file that I'm reading, for example, we are reading test1.txt. Okay, so it does not have any particular variables. So if you look at this file test1, it has these values. Okay, and there is no name for these values. So what would be the name of the workspace variable in which these values would be loaded? So the name of the file test1 will be used as the name of the workspace variable into which this data would be loaded. And these are like numbers. These are ASCII characters, but these ASCII characters represent numbers. These numbers would be stored in a double array. Okay, so all these numbers will be converted into double. So 45 would be converted into double value, 69 would be converted into double value, 87 would be converted into double value. All these values would be converted into a double value, and the name of that variable would be test1, since test1 is the name of this file. So you need to specify to the load function that I want to read this particular text file, and you need to specify it to the load function that this is a text file. Okay, so you need to specify the format. This is the format of the file. So the format is ASCII. Okay, and you need to put this dash character before you specify the format. Okay, so this is basically syntax requirement. Now you can look up the documentation of the load function, and there you will get more detailed information about all this thing. But if you want to read a text file, this is how you read it. Okay, so if you press enter, and if you see here, you will have a variable test1. Okay, so you can display test1 here. You can say test1. Okay, so this is test1. Now all this is an array 11 by 1 characters. So we have an array of 11 by 1 characters. Okay, we have this array. Let me close this file. Okay, so this is test1. Let us take a transpose of test1, and all this is double. This is a column vector, and it is a column vector of type double. It is a column vector of type double. Okay, so let us say it is double column vector. Let us convert it into a row vector, for example. So we want to convert it into a row vector. We need to transpose it. Okay, so if we have transposed it, and then you can print test1. So now it is a row vector. Let us say we want to save it. We want to save the row vector test1 now. Okay, so how can we do that? In order to save any workspace variable into a file on your hard drive, you can use the save function. So let us learn about the save function. Okay, let's learn about the save function. Now the save function, this is how you write it. This is how you write the save function. The arguments. So first of all, you need to specify the file name. Where should you save on your hard drive? In which particular file should you save the workspace variables that you want to save? So say we want to create another text file, test3.txt. So we want to save variables in this particular text file, and if you notice, now I'm using single quotes. Okay, so the point is to demonstrate that you can specify the name of the file in the form of a string using single quotes or double quotes. No problem with that. Okay. Asha, now which variable do we want to save here? We want to save this variable test1. Okay, we want to save this variable test1. So we need to specify its name in single quotes as well. Okay, as a string. And how do we want to save this data, in which format? So this is a text file, so we want to save it in the form of ASCII characters. Okay, so this is how we want to save it. So if you press this button, so you can also see here you will have a new file, test3.txt. You can open that file in this folder. This is a new file that has been created. You can open this file, and here you can see now, like, all the variables, all the values in this variable, they have been stored in a row, and they are separated by space characters, and they are stored in double format. Okay, so this is double format. This is how double values are stored. Now this is completely different from this thing. When we read this data, so it was in this particular form, and we basically changed its form and then saved it using in the ASCII text format, and this is what we ended up with. Okay, this is what we ended up with. So these are all ASCII characters. Okay, so this is one ASCII character, this is another ASCII character, this is another, this is another. So these are 1 2 3 4 5 6 7 8 9 10 11 12 13 14 ASCII characters. Each double value is stored in 14 ASCII characters, or 14 bytes. Okay, 14 bytes. So these values are stored here. You can read this value, like we can read this value. Say for example we have this variable a, and I want to initialize a with the values stored in test3.txt. So I can say a is equal to, and then I can say load, and then let us load the values stored in test3.txt. Okay, so here we need to specify only one thing. This is ASCII. You don't need to specify the name of the workspace variable, because that information is not stored there. Okay, that information is not stored. So now we have a. Okay, a type is double, dimension is 1/11, and it is the same variable as test1. Okay, it is the same variable as test1. You can verify it if you say a minus test1, so you will get zeros. Okay, so the point, like, I hope, like, just wait.